And welcome back to Mr. Gregoris Math. In this video, we're going to evaluate a definite integral, and we're going to learn how to do this by hand, and I'll also show you how to do it very quickly on the calculator to check your answer. So first off, let's read what the expression is telling us to do. It's saying evaluate, which usually means we're going to come up with a value. So we're going to evaluate the integral of 1/3 cosine theta with respect to theta, from theta being pi by 3 over to theta being 2 pi by 3. And just a quick sketch of a cosine graph here is going to give me between, that was a sine graph. There we go. So pi by 3 is going to be here, and 2 pi by 3 is going to be here. So it's going to give me the area from here to here. So actually, I expect that this is going to end up being equal to 0, even when we apply a transformation of 1/3 to the function. So let's go ahead and do the work anyways, just to confirm that that is the answer that we get. So the first step is we actually integrate. So we have to integrate 1/3 cosine pi, or cosine theta. This 1/3 is a constant, so I can remove it. And I'll have pi by 3, 2 pi by 3, and cosine theta d theta. Now, the integral of cosine is equal to sine. So I have 1/3 sine theta. Now, that 1/3 sine theta is actually 1/3 outside of the integral. When I go ahead and integrate here, normally I would have a value of plus c. But because I have a definite integral, I don't need that value of plus 3. Because what I'm going to be doing is actually evaluating this expression in the square brackets for both pi by 3 and 2 pi by 3. And I indicate that with this vertical line. So my integration goes from my sum line to this vertical evaluate line. And I put my lower bound on the bottom and my upper bound on the top, or my left bound on the bottom and upper bound on the top, right bound on the top. So what this means is I'm going to go through and I'm going to replace first theta with 2 pi by 3. So I start with my upper bound. I go sine 2 pi by 3, replacing theta. Then I'm going to subtract sine of pi by 3. And so that's how I go from this vertical substitute notation into an expression that shows that I've done that. This is just talking about the difference of the function from this value to this value. And so we start with our top and subtract our bottom. So now I'll evaluate sine of 2 pi by 3. I always draw my triangles. So the sine is going to be root 3 over 2. And the sine of pi by 3 is just this related angle in the first quadrant. And so again, that's going to be the same thing. It's going to be root 3 over 2. And so I'm going to have root 3 over 2 minus root 3 over 2, which is going to work out to be 1/3 times 0, or in fact 0. Now, why that worked is because when integration happens in both a positive, so above the x-axis, and negative below the x-axis, it actually subtracts those areas. So it'll treat this area between pi by 3 and pi as a positive area, and it treats this area between pi and 2 pi by 3 as a negative area. And since we're symmetrical about that value of pi, or at point rotationally symmetrical, we're going to end up having those things cancel in this case. Now, our answer is correct, and we think it's correct based off of this graph, but let's see how to do this on the TI-84. So I'll turn on my trusty TI-84, and I'll press Math to bring up integration, and I'll go 9. And so this brings up a place for us to type in exactly these expressions. So I'm going to use my fraction button, so that way I can make it look exactly like I would want it to. So I have pi over 3 and 2 pi over 3. And I'm integrating the function cosine. And I know I don't really have a theta, and I haven't figured out how to change it to theta, so I'm just putting x here for cosine of x and dx. So this expression is exactly equal to this one. Oh, except wait, I forgot the 1/3. Now, I could just do the answer and multiply whatever I get by 1/3, but I'm going to go ahead and insert it because I want it to actually be there. So I'm going to go second function, delete to insert, and I will insert this fraction of 1/3. Just so that way it looks exactly the way that I typed it. I'll hit enter, and shockingly, I get 0. So your calculator saves you a whole bunch of steps. And actually, it can integrate any function that you put into it. It'll be as accurate as the resolution if it's using some other technique. But in many cases, it actually uses a very good process for getting to the correct answer as well. So it should be accurate within 3 decimal places, and it'll give exact value answers if those are easily findable. So that is evaluating a definite integral. Join us next time on Mr. Grigoris Math, where we'll be talking about more interesting definite integrals. And don't forget to hit like, subscribe, and ring that notification bell.